various relationships. That means if in a particular model or if in a particular design, if there are many number of relations exist, then how we have to design that particular model. For example, if you consider a use case diagram, we concentrate or we consider only association relation, that too a unidirectional association. And we consider the sequence diagram, we consider only the interaction in between the objects. That means one particular relation exists for one particular diagram. Only one-to-one existence will be there. Now, this topic says about webs of relationships. That means networks of relationships. That means many groups of relationships. If many relationships like association, dependency, generalization, realization, composition, all these relationships exist in a single model, or do we have to use all those relationships in the same model, then how we have to construct or build our design like that. Okay. UML is a modeling language, provides different mechanisms to model various kinds of systems. Okay, there's nothing there in explaining that point. It is a design language in which various kinds of systems can be defined, like library management, hospital management, railway reservation, ATM system. These are the various systems. So all these various systems are designed or represented easily by using UML, that is Unified Modeling Language. And if the model consists of classes, interfaces, nodes, use cases, components, that means various components or various tools or various classifiers exist in a particular single model, then the model becomes, the size of the model will become large, or the representation will become a complex representation. So if all these things are present in a single model, that too in large numbers, it becomes difficult to represent. The model will become difficult to represent. Then the steps to model webs of relationships are, so the networks of relationships can be represented by the first one, identify different relationships existing between different abstractions. Here abstraction is nothing but a class. Because our unit name is advanced classes, we are discussing from since many days we are discussing about classes, right? That's why here abstraction is nothing but a class. You may ask me a question like, why a class is considered to be as an abstraction? Because a large use case diagram, which consists of many actors and many use cases, can be replaced with a single class diagram. For example, you may ask that why you are saying that a use case diagram can be replaced with a single class. Single class. For example, consider a use case diagram consists of only one actor and 10 or 20 operations are there, or 20 use cases are there. Use case is nothing but they are the actions which are performed by an actor, right? That's why all those actions can be represented in the form of attributes or operations and responsibilities, like that. A single use case, sorry, a large use case diagram can be represented with a single class, like that. Next, identify different relationships existing between different abstractions. So we need to first of all identify which relationship is apt in order to connect one abstraction to another abstraction. If any inheritance relation exists, then we need to go for generalization relationship. If there any whole part and subpart kind of a thing exists, then we go for aggregation. If there is a contract between one entity to another entity, like must and should, that entity has to do this particular kind of thing, then we need to go for realization. If we want to establish communication in between two entities, then we need to establish association, like that. Next, start with structural relationships. We need to start with structural relationships, which is static methods. Static method in the sense, whenever if we start representing the relationship between one entity to another entity or one tool to another entity, we need to stick to that kind of relationship. We're not supposed to change it in the middle, because if we keep on changing means definitely it affects the design process. That's why we need to stick to one particular design. Next, generalization, specialization should be added if necessary. In this, multiple inheritance comes into picture. Okay, generalization we have to add if we consider that some parent class exists and some subclasses also or child classes also exist. Child classes are the classes which inherits the properties of the parent class. You are aware of this point. Next, now implement dependencies. If needed, we need to implement the dependencies also. Apply advanced features for the relationships. Advanced features in the sense taglines, stereotypes, interfaces, like that. Implement different relationships in the system by viewing it through different levels of perspective. Implement different relationships in the system by viewing it through different levels of perspective. Different levels of perspective in the sense, for example, if you are manufacturing a particular PC, your personal computer will be manufactured in different perspectives. First, each and everything will be developed or manufactured separately, and all those things are accumulated or integrated or collaborated with one another in order to get the final design or final product. After completion of the roll number by E series is not in your class, right? 11. Implement different relationships in the system by viewing its different uh, implement different relationships in the system by viewing it through different levels of perspective. After completion of the keyboard, that means after the manufacturing of keyboard, we'll have one kind of perspection. After completion of the CPU, we will have another kind of perspection or another kind of look we can have. After completion of the monitor, we will have another kind of perspection. Like each and every after completion of the each and every concept, sorry, each and every part will have one more type, one more perspection, one more thing will be added into the our perspection, like that. Next, interfaces, types, and roles. These can be defined as the specification of what an abstraction does and the implementation how that abstraction does it. So an interface is nothing but it implements the service of a class, which implements the service of a class. That means there is, particularly in interface, there is no need to present attributes, only operations if needed. Responsibilities, I think they are also not needed to include in the interface. Only it implements the or it concentrates over the services which is given by the class to the user. Next. It is a collection of operations that are used to specify a service of a class or component. That's what I said now. Types and roles provides a mechanism to model the static and dynamic conformance of an abstraction. So types and roles, role in the sense, for example, if you remember while discussing about the various adornments or various representations of the association relationship, I used these, that means I have explained these things. The type and role I have explained there. For example, a boy and school is there. Consider those two classes exist. Boy acts like a student or girl acts like a student, and in a school a teacher will be there. Here student and teacher are nothing but they are the roles, like that. A type is also nothing but whether it is a static type or a dynamic type, like that kind of a thing. Next, it characterizes the behavior of an element. So interface characterizes or interface concentrates on the behavior of the element. The next one, it describes the externally visible operations of a class. comma, component or package without specifying the internal structure. So the operations or responsibilities will be displayed externally. We won't concentrate on the how those operations are, how those responsibilities will carry. Interface, the use of interface is that only that thing only. Only the services will be highlighted or functional requirements. Next, operations in interface have visibility properties, concurrency properties, tagged values, and constraints. Here, visibility properties are nothing but visibility markers like public, private, protected, and packaged. Public can be accessed by each and every abstraction or every class uh, within, inside, and outside of the model. And the private is only restricted to only that particular class, only that particular single class. And protected attribute and as well as protected operation can be accessed only by the classes which have parent-child relation. That's all. And packaged attributes and packaged operations will be accessed only by the classes or abstractions which are there in a particular model or a particular design. That's all. Next, names. That means the names of the interface. Every interface must have a name which distinguishes from other interfaces. In order to differentiate with one interface to another interface, we need to name specifically. Either it is an actor or a class or an interface or an state machine or an activity node or a component or a deployment node, whatever it may be. Each and every part which we are representing in the model has to be different from one thing to another thing. For example, two types of names exist. The first one is simple name and second one is path name. So the first representation explains about the simple name. That means no prefix or no suffix is there with this simple name. The next one is path name. So router is the name of the interface, and networking is the package name. Networking is the package name. In networking only, we will come across the routing techniques and remaining things, right? That's why the name of the interface should be preceded with the package name, which is considered as a path name. Next, operations. An interface is a collection of operations used to specify the service to class but not implements them. This is the point which I'm saying from the start of the class. Interface concentrates only on the operations which specifies the service to the class or the service of a class, but it won't concentrate how those operations are, how those services are, how those functional requirements are implemented. And these operations can be or cannot be adorned by visibility. These visibility markers we can use, or there is no rule to use the visibility markers. But if you want to more specific about the type of operations which we are using, then we need to go for these visibility markers. Along with in addition to these visibility markers, we need to go for concurrency properties like concurrent operations and stereotypes, tagged values, and constraints. Tagged values, it provides additional information. Constraint specifies the rules, which rule we need to follow while representing the model or specifying the model, like that. Next, declaring an interface includes rendering an interface as a stereotyped class and list all the operations in it. Read this statement again. Declaring an interface includes rendering an interface, that means representing an interface as a stereotyped class and list all the operations in it. An interface is always represented in the form of stereotyped representation, which is nothing but in angular brackets we represent the interface. Stereotype is nothing but what is the advantage of stereotype means definitely I think you have a bit in your mid exam. What is the multiple choice, right? What is the significance of stereotype, or like that kind of a thing? That means for normally these interfaces will come into picture while discussing about the classes. In order to restrict the size of the class, like in order to restrict the number of operations and number of attributes, we'll go for stereotypes. All the similar type of attributes and similar type of operations can be grouped together and be placed under a common name, which is called as a stereotype. Next, relationships. Interface parti participates in generalization or association dependency and realization relationships. So we can use these commonly used relationships along with this interfaces concept. Okay, we can go for another concepts also like aggregations and compositions, but normally they are used in classes but not in interfaces. The first one says about an associated interface. That means a class is connected to an interface through an association. That too a bidirectional association. That means a two-way communication exists like that. We need to think like that. Next, a tracker, observer, target tracker. So a dependency relationship has been established in between the tracker and the observer. So this tracker acts as a dependent entity and this observer acts as an independent entity. How I can say that this is dependent and that is independent, like to which element or to which class or to which component the arrow is pointing out. That particular component is considered to be as an independent entity from where the relation is starting, that is considered to be as an dependent entity. So whatever the changes we made for the independent entity, definitely it's going to have an impact on the dependent entity like that. Next, a realization relationship has been established in between the target tracker as well as the observer. What do you mean by realization? Can anyone type the answer in the chat box, or you can, if you are interested, you can unmute yourself and you can let me know about the answer when we have to use the realization relationship. Any one of you? My question is, what is the significance of realization relationship? No, your answer is wrong. Any other? When we have to use a realization a relationship in between the tools or classes or components or classifiers or whatever it may be. Hello, any other answer? I got one answer in the chat box, which is wrong. Dilip, Lavan, Nitya, Mukul, Tirumalesh, Lakshman, Sai. I don't know the full name. Only if I can see a name called Sai here. Who is KVR? Roll number L8. I think roll number N4 is Sarvesh. Vinay, K. Vinay, I think. Lateral student. Any one of you? No, no answer. Yes, all of you remember one thing. I'm not getting any answers from you people. Only So I ensure that I won't give my notes for you people in order to prepare. You have to prepare by yourself by seeing the Google or whatever it may be. I'm explaining by seeing the notes, but if you ask the note means definitely I won't give. That is for sure. When we have to use a realization relationship in between two classifiers. No, your answer is wrong. A realization relationship will be used in between two classifiers where the first classifier ensures a contract with the special second classifier to carry out the work. Normally, it is used in between a collaboration and as well as a use case. So collaboration, in the place of collaboration, if I say a manufacturing department, this is the example which I have been saying from the first unit onwards. But you people are not, what I can say. Definitely the manufacturing one model, no. So realization relationship says that one classifier ensures a contract to carry the work by another classifier. For example, a collaboration is there. Inside the collaboration, we have the name as manufacturing department. So what a manufacturing department will do, it manufactures a product. So it the first consider the first classifier or the first component is a manufacturing department. Consider the second classifier as a to manufacture a product. So the first classifier is ensuring a contract to carry out the work which I said, that is manufacturing a product. Then in between those two classifiers, we have to use realization relationship. Next, modeling the seams in a system. Common modeling techniques, modeling the seams in a system. Seams is nothing but the working procedure or like kind of a thing. It is done by using interfaces. Okay. In some situations, the software components can be reused from another system, maybe purchased off the shelf. In some situations, software components can be reused from another system or maybe purchased off the shelf. That means each and every time while developing a particular model or designing a particular model, we won't go for a damn new kind of tools. We reuse the tools which have been used previously. That means in order to restrict the budget of the model or the budget of the system or the budget of the product, we reuse the products again and again like that. Other components can also be created from the damaged systems. So other components can also be created from the damaged systems in the sense, if any particular model is considered as a defective model or a particular tool is considered as a defective thing, for example, the best and simple example what I can say is, for example, if you are using your PC and it got affected with full of virus, and what you will do, you just throw your system in the dustbin or what? You will install the antivirus and you will format your system and you will reboot your system or whatever it may be, and again you will start using your system like that. I can associate or I can relate, or I can give this type of example for this point. Other components can also be created from the damaged systems. In the above situations, a glue code which helps in wearing the components together is needed to be written. A glue code is nothing but the meaning of glue code is nothing but the code which associates or which collaborates or which combines all the components together. The reusing techniques or whatever it may be. Reusing techniques in the sense using the same tools, same components, the same classifiers again and again, like that. To identify the seams in a system, the declaration lines present in the architecture must be identified. So it is not declaration, it is a demarcation lines. To identify the seams in a system, the demarcation lines present in the architecture must be identified. The meaning of a demarcation line is nothing but these are the components lies either side of these lines. That means so what I can say is some benchmarks will be there, uh, kind of a thing. Benchmark is nothing but mm, minimum and maximum, mm, some minimum standards we need to follow. Those standards in this particular UML, Unified Modeling Language, can be represented or can be said by using this word, which is called as demarcation line, which is nothing but a benchmark. Next, for reusing the components from the other systems, two factors are associated, essential. So if you want to reuse the products which have been used previously, we need to concentrate on two things. The first one is order in which the operations must be performed. So operations has to be carried in a sequential manner only. That means in waterfall model only, we need to start our developing process or designing process. Underlying mechanisms which the interface uses. Underlying mechanisms which the interface uses is nothing but the internal concept or the internal theoretical explanation is to be highlighted more. Next, for creating components, a component is nothing but a part, a individual part in entire system. A component is nothing but an individual part in an entire system. For creating components, factors to be considered are components context and interfaces. Components context is nothing but how these components are related to one another will be explained by using this components context. Interfaces is nothing but which says about the services of a class. In order to model the seams in a system, the following steps are considered. Seams in a system is nothing but the working procedure of a system. In order to represent the working procedure of a system, what are the steps we need to follow? The first step is line is drawn around a set of classes and components which are similar to each other. So line is drawn around a set of classes in the sense we need to identify the similar type of classes which have the same type of attributes and operations, like that. That means we need to group all those classes together. In some location, we need to place all those things, like that. Next, classes are components that tend to change or group together. The first point says about the classes which comes under same groups are grouped together or placed together. And in the second group, the classes which changes according to the user requirement or the client requirement or keeps on changing, like the attributes and operations keeps on changes means then we need to group those classes separately. Third point, operations are related to a single set of classes or components, and those that are related to other set of classes and components must be considered separately. So the third point also speaks about the first 2 points only. The static classes can be have to be grouped together, and the dynamic classes have to be grouped together, like that. Next, operations that are related are packaged together. Operations that are related are packaged together in the sense we need to use the stereotypes. Operations which considered to be as a similar type, they are to be considered as one group, and we need to place stereotypes at the beginning of the representation. Next, for every interface present in the system, the changes done to it must be documented. So here documentation is a important point to remember. Because we need to establish or we need to keep a note of all the things which we are doing on a paper or on a text document or whatever it may be, like that. Soft copy or hard copy has to be maintained, whatever the things we are doing, whatever the changes we are doing to a particular system. Here a diagram is given, an interface is given which is with the name I unknown, and a list of operations are there, sorry, list of attributes are there, and one component is there, and another interface stereotyped class is there. So in between this I unknown interface and ledger component, a realization a relationship has been established. So what a realization says, it ensures a contract in between the classifiers in order to carry out a particular work, like that. And dependency has been established in between the ledger and as well as the I transaction. Here, I transaction is considered as an independent entity, and ledger is considered as a dependent entity. It is a ledger is a component because it is represented in the form of a component tool. So, I transaction, if any changes have been made to the I transaction, it affects the ledger. Ledger in the sense account sheet kind of a thing. Ledger is nothing but in normal terminology, ledger is considered as an account sheet or account record. Next, modeling static and dynamic types. So static and dynamic types in the sense how um, design which is considered to be as static, that means no modifications will be occurred after the designing process. Then what steps we need to concentrate, and dynamic types are the systems where we need to keep on changing the tools and the relationships and the design process has to represent. That is the concept. And I will continue in the next class because it takes more time in order to explain. So I'm stopping here. You may leave the class.